Hello, this is Ms. Poor, and we are going to work on lesson 407, Triangle Congruence, AAS and HL, Part 1, and we'll find out what those letters stand for in just a second. Please remember to give me your course and section number with all communication. I have a lot of people sending me K-mails without that information. It helps me help you faster if you can get it to me. Your course number is 203A or 204A. Your section number will be 1, 2, 3, or 4. Today's objectives, you're going to learn to identify the congruence postulate or theorem that proves two triangles are congruent. And you're going to use the hypotenuse leg, which is HL, or the AAS congruence theorems to prove congruence. First, let's remember what a hypotenuse is. Whenever you have a right triangle, the side opposite the right angle is the hypotenuse. And I've highlighted it in purple there so you can remember which part it is. The other two sides are called legs. Let's do a little bit of review of right triangles right quick. Right triangles always contain a right angle. That is, it's a 90-degree angle. And you see that right down here with B. A right angle is indicated by a small square placed in that angle, just like we see in the picture. The side opposite the right angle is called the hypotenuse, which we just talked about on the previous slide. And the other two sides are called legs. So segment AB and segment BC are the legs. And do not forget that a squared plus b squared equals c squared is how we find the measure of a leg or the hypotenuse. And you're going to find in my examples, I usually let the shorter leg always be A, and the longer leg will always be the letter B. However, you can interchange A and B. It doesn't matter. It's just habit for me to always use the shorter leg for A. Okay, let's talk about the AAS theorem. It's AAS stands for angle, angle, side. And it says if two angles in a non-including side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the two triangles are congruent. And you can see in these pictures, you've got A and B correspond with X and Y. And all of those angles, A and X are congruent, B and Y are congruent. And then you have the non-included side, which is AC, corresponds with XZ, and those are also congruent. So this would fit in to the angle, angle, side congruence theorem. We also have the hypotenuse leg theorem, which we abbreviate HL. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg, or corresponding leg of another triangle, then the two triangles are congruent. And look at that. I copied and pasted this theorem and they misspelled the word two. They said toe. I'll have to look in the LMS and see if it stayed that way. Okay, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the two triangles are congruent. And you can see in this picture how that works out. Okay, so let's get into some examples. It says determine whether the triangles can be shown to be congruent by the angle, angle, side, or hypotenuse leg congruence postulates. If so, write a congruence statement and the postulate you use to justify your statement. Now remember, we just learned two theorems, okay? So, I'm trying to get my pen down here. There we go. We just learned two theorems, so those aren't what we're going to use to justify our statement. All right? Let's look at this. We know that we've got right angles down here. And the reason is because of this little box. We also know that AB and BC are congruent to each other. So I'm thinking since we're dealing with the right triangle, we might be using the HL theorem here, hypotenuse leg. So, let's think of something else. We know that BD is going to be congruent to itself. if I were to separate these into two triangles. And think about this, BD is congruent to BD, and the postulate that I'm going to use to justify that is the reflexive property. So if BD was looking in a mirror, it's going to see BD. So BD is going to be congruent to BD. So that's how that works. So these triangles will be congruent based on the hypotenuse leg congruence. It says postulates up here, but these are theorems. Okay, let's look at the next one. All right, let's look here. Again, we have right angles, and we have a leg that's congruent. All right, but we don't know that the hypotenuse is congruent. So let's think about this for just a minute. How could we figure this one out? We know, let's go ahead and write down what we know. We know that, oops, angle, let me see what this is, DEF is congruent to, trying to make sure yeah, okay, I did it right. Congruent to KJL. I was making sure my corresponding vertices were corresponding in my statement. We know that's true because it's given. Now then, we also know that angle LKJ is congruent to angle, let me make sure I get this right, FDE, because they're both 90 degrees. Okay? So we've got two angles, and we got segment DF is congruent to segment LK, and that's given in the figure, and those are sides, and they're non-included sides, because remember, angle side says that side's not included between the two angles. So we can prove this with the angle side theorem. And the reason that we know that these two guys right here are congruent is because we know the definition of I wrote that too soon, right angle. Okay? Oh, another proof. I bet these are wearing y'all out. But I want to make sure y'all get this down, because if you've noticed on the Part 2 test, they like for you to fill in information about proofs. So if we look at the first statement, it says segment AB is perpendicular to segment AD, and segment DE is perpendicular to AD. We know that information because it's given right up here. All right, let's look at our picture too. We can see that they're perpendicular. They show us in the picture because perpendicular lines make right angles, okay? And then it tells us point C is the midpoint of segment BE. Remember what midpoint tells us? That segments are going to be congruent. So that means BC is congruent to EC. So notice when I'm going through and I'm going through what's the information that's given to me, and I'm marking up my figure, I'm actually proving it orally to myself. Now what I got to do is take that information that I just said out loud, and I have to put it in writing. Now remember, we've got our if-then statements, but you don't have to write an if-then statement if you can just use your noggin and see the connection, okay? But so I'm going to say the if-then instead of writing it out. Remember, your if is always a previous statement and your then is the current statement. So if I say this. If segment AB is perpendicular to segment AD and segment DE is perpendicular to segment AD, then guess what? Angle A and angle D are going to be right angles. And I know that because of the definition of perpendicular lines. Okay? And remember that definition? It says when two lines intersect each other to form right angles, then they are perpendicular. So if I use that converse of that definition, I say if two lines are perpendicular, then they intersect to form right angles. Okay? Got a little information here. Let's just move that right out of the way. Oh, got more information. Let me remove that out of the way too. Okay, oh, more information. I'll just minimize that. Okay, so angle A is congruent to angle D. Okay, if they're both right angles, think about it, okay? I'm using my if-then. If angle A and angle D are right angles, then angle A is congruent to angle D. Well, how do I know that? Hello, they're both 90 degrees. So you could write down here, well, you know, we could put definition of right angle. That will work. As a matter of fact, that's what I'm going to put. Definition of a right angle. Because we know a right angle equals 90 degrees. 90 degrees is going to be the same measure as 90 degrees. Therefore, angle A can be congruent to angle D. All right. Let's look at part D. It says point C is a midpoint of segment BE. Hello, look up at the top. Given information. Okay. And notice that A, B, and C, I said when they told me they were perpendicular, and I went up there and marked that, I said all of that out loud. Now let's see if I said everything about statement D. Now then, I know since C is the midpoint of BE, I know BC is congruent to CE. And remember, I put my little tick marks up here showing those two guys were congruent. And hello, we know that because we have the definition of a midpoint. So, that's what I'm going to write down here. Definition of midpoint. So, then we look down here and we say angle, it says angle ACBE is congruent to angle DCE. Well, let's see what ACB is. Oh, right here. And they're telling me it's congruent to DCE. Now, I did not mention that out loud because I really didn't go that far because I was just looking at my gift. I can go in and say that those angles are congruent to each other because don't I have a intersecting lines that are going to form vertical angles? Okay, so you're going to have to remember information that we've learned in prior units. Okay, so part G says that triangle ABC is congruent to triangle DCE. And that's what I was having to prove. And the reason that I can say that is, look up here at my picture. I've got angle, angle, side. Oh, angle, angle, side. And that's all you need to put. Alright, so that's a proof that's down and out. Let me find my little arrow here. There we go. Okay, this says determine what one other side or angle congruence pair is needed to prove the triangles are congruent, and then state all possible congruence postulates that apply. Some problems could have more than one possible solution. Well, that's hurting us, because then we're going to have to think harder. Okay, let's look here. I've got an angle and an angle. Well, since I'm learning about angle, angle, side, and HL here, wouldn't it go to say that if I can prove ON is congruent to CB, or I could say CD is congruent to MN, then I could use angle, angle, side. So if I could say, let me write this out, angle NO is congruent, angle, segment, is congruent to CB, or I could say NM is congruent to CD, then I could use the angle, angle, side theorem to prove these two triangles are congruent. And that's what you would need to answer this question. You would need to write one of those in that theorem. That's all you would have to do. Okay, let's see what's next. Same situation. We got to prove that they're working out here. What I would need to know here is that the hypotenuse is congruent. Now let me see. Let me take that off because I marked the wrong one. The way that I knew that, I'm dealing with right triangles, and I've learned that if I have a hypotenuse and leg that are congruent in corresponding triangles, then the triangles are going to be congruent. So I have the right triangles and I have a leg. Okay, so that tells me if I prove the hypotenuse are congruent, so let's say LY is congruent to RT, right? Then I can use the hypotenuse leg theorem to prove these triangles are congruent. Okay, let's see what's next here. Oh, summary. In this lesson, you proved two new theorems that you can now use to prove even more theorems, the AAS and the congruence theorem HL, or hypotenuse leg. Now then, we didn't actually go through and prove all of them in this lesson. You can look in your LMS and see those proofs, all right? Now then, what you should be doing when we get finished watching this video is read through the LMS lesson 407, isosceles triangles. No, it would be the AAS and HL theorems, and complete the student guide. And that's not what's next. Let's see what's next. Oh, and then read pages 117 through 120 in the reference guide and complete the following problems in the problem set. And when you get done with those, if you are not understanding these concepts, you need to contact me or attend TOGA before you complete the 407 quiz. And please make note of any general questions you may have when you attend CC on Thursday. That's going to be it for lesson 407. Thanks for listening.